In the first video about area under a curve, we talked about how to approximate the area using left and right sums. So the area of rectangles either from the left side or from the right side. In this video, we're still talking about how to approximate area under a curve, but this time we're going to use two different methods, and that would be rectangles with a midpoint method and then trapezoids. This is a fundamental concept in calculus that we build on. If you take calculus, you will see this again. Okay, so first thing I would like you to do, this is one of the graphs that we used in part one with the left and right sums, but I want you to shade the region that's bounded by the function x squared plus 2, the x-axis, the y-axis, and the vertical line x equals 2. So if you shade in that region, we are talking about finding the area of this graph, this region bounded by those four lines. Okay, now notice we can't just use a geometric formula again because there's a curve to this. So we have to be able to approximate. Okay, so when we're approximating, we can use rectangles or trapezoids. In this case, we're going to use rectangles using a midpoint method, not a left sum or a right sum, but a midpoint. And again, I will tell you how many partitions to use. This time we're going to use 4 partitions of equal width. Okay, so if I'm using partitions of equal width, remember to figure out what the width should be. I can take my x values, the starting and ending x values, and divide by the number of partitions. So in this problem, that would be 2 minus 0 divided by 4, giving me a width of a half. So I'm going to draw a line at all the halves. So we're starting at 0, and then a half, at 1, at 1.5, and at 2. And I'll remind you that you really want to not try to draw these graphs too small because then it's hard to see what you're doing. Okay, so I've got this split up into 4 sections of equal width. Okay, now if I'm going to make a rectangle using the midpoint method, then I need to find the midpoint of these regions. Okay, so what is halfway between 0 and 0.5? Well, the halfway would be 0.25. So at 0.25, I'm going to come up here, put a point on my curve, and that's where I'm going to flatten my rectangle out. Okay, halfway between 0.5 and 1 would be 0.75. So I'm going to come up to the curve at 0.75, and then I'm going to flatten out to make my rectangle. So you'll notice that this time when we calculate area, we're on one side of the rectangle, we're getting a little too much area, but over here, we're leaving out some area. Okay, so this is going to balance out a little bit better than the right or left sum did. Okay, halfway between 1 and 1.5 would be 1.25. So again, I come up to the curve at 1.25, and then I flatten out the top of my rectangle. And then halfway between 1.5 and 2 is 1.75. So again, that's the point where I'm going to flatten out my rectangle. Okay, now how do you find the area of the rectangle again? Area is length times width. Our width we already said was 1/2. And our length is going to be found by the y values when x are those midpoints. So for the first rectangle, area of the first rectangle would be 1/2 times f of 0.25, the y value when x is 0.25. For the second rectangle, our width is still 1/2 because they all had equal width, but now it's times f of 0.75. Okay. And then we do 1/2 times f of 1.25 for the third rectangle. And then the fourth rectangle is again 0.5, but now it is the y value when x is 1.75. Okay, so when we work out these areas, okay, we are going, and I did mine in fractions, so when I put in 0.25 or 1/4, I end up with 1/2 times 33 over 16. Where did the 33 over 16 come from? Well, remember our function f of x was x squared plus 2. So f of 1/4 or 0.25, 1/4 squared plus 2 would be 1/16 plus 2, and when I get my common denominator, that's where the 33 over 16 comes from. Okay, so I'm going to go through the rest of these numbers pretty quickly to save time, but if you can't figure out, I want you to work them out and see if you know where the 41 over 16 comes from, and so on. If you can't figure that out, you need to put a question mark in your notes and ask me about it when you come to class. Okay, so the 81 over 16, the 57 over 16, 41 over 16, and 33 over 16 are what we get from putting in 0.25, 0.75, 1.25, and 1.75 into the f of x equation. When you multiply that and add it together, you should come out with an approximate area of 53 over 8. Okay. Now again, that's just an approximation. It is better than a left or right sum because on some sides you're getting too much area, but on the other side you're not getting enough area. So it kind of balances out. It's not perfect because those regions are not equal. Okay? But it is better than a left or a right sum. Okay, now one other method that we have to approximate area is called the trapezoid method. And again, we're still going to use the same region, x squared plus 2, and bounded by x equals 2 and the x and y axis. We're going to use 4 partitions still of equal width, so they're still going to be 1/2 width apart. So let me draw those lines in. And for each one of these problems, you should draw a new graph. Do not try to draw these on top of each other. You won't be able to see what's going on. Okay, but this time we're going to use a trapezoid. So the first thing we need to know is what is the area of a trapezoid. So the formula for area of a trapezoid is 1/2 times base 1 plus base 2 times the height. And the height in this case, our trapezoids are going to be sideways. The height is actually going to be what we were using for width before. Okay, so the height is going to be our b minus a divided by n formula. So on all of these problems, the height will be 1/2. Okay. Okay, now to make our trapezoids, we're going to connect the left side to the right side. Okay. Okay, so you'll notice that follows pretty closely along the curve. It's not perfect, and we are going to leave out some area where we might get a little too much in some cases, but our trapezoids are better approximations than the left and right sums again. Okay, so base 1 and base 2, this is our first trapezoid. I'm going to put area 1 here. So base 1 and base 2 are going to be the y values for those x numbers. So that's 0 and 0.5. So to get the area for trapezoid 1, okay, our formula is 1/2, and I'm going to put the height in the front with the other 1/2. So times another 1/2. The first 1/2 is from the formula, the second one is the height, times base 1 plus base 2. Well, base 1 is going to be f of 0, and base 2 is going to be f of 0.5. So that's the area of our first trapezoid. Now let's look at the second trapezoid. Okay, our height's still at the bottom. It's still going to be 1/2. So 1/2 from the formula, 1/2 for the height. Now this time our base 1 is on the left side and our base 2 is on the right side. So base 1 is f of 0.5 and base 2 is f of 1, the y value when x is 1. Okay, for area 3. Okay, again, 1/2 for the formula, 1/2 for our width. Okay, but now our base 1 on the left side would be f of 1, the y value when x is 1. And base 2 is on the right side, which would be f of 1.5. Okay. Now, we've got one more trapezoid to go. So the fourth trapezoid, and again, we're adding all this. I ran out of space, so I'm going to a second line. 1/2 for the formula for the trapezoid. 1/2 is our height of our trapezoid. Again, the height is down here at the bottom. Our trapezoids are sideways. And then our base 1 is the side on the left, so that's f of 1.5 plus base 2 is on the right side, so f of 2, the y value when x is 2. Okay, so now we need to plug those numbers into our equation, f of 0, f of 0.5, and so on, and get those numbers, and we're going to multiply all this out. Okay, so for the first one, got 1/2 times 1/2, which is 1/4. F of 0 comes out to be 2. Remember, f of x was x squared plus 2. So if I put in 0, 0 squared plus 2. Okay. And f of 0.5 is 9/4, or 2.25. Okay. And then for the second trapezoid, 1/2 times 1/2 is a 4th. When you put in 0.5, which we just did, we got 9/4. When you put in 1, 1 squared plus 2 is 3. Okay, for the third trapezoid, again, 1/2 times 1/2 is a 4th. F of 1 we just found to be 3. When you put in 1.5, 1.5, you come out with 17/4. Okay, and then for our last trapezoid, 1/2 times 1/2 is a 4th. Okay, then we would have 17/4 again for the f of 1.5, and f of 2, 2 squared plus 2 is 6. When you add and do all the multiplication, your final answer should come out to be the area of the region is approximately 27/4. So put that in your calculator, see if that's the answer you get. If not, put a question mark beside it. So the trapezoids are working on the formula for the area of a trapezoid. Left, right, and midpoint sums are the formula for the area of a triangle. Okay, now let's look at another example using these two methods. Okay, and again, this is a region that we used in video 1, 9 minus x squared for f of x. X equals 0 is the y-axis, y equals 0 is the x-axis, and the line x equals 3. Okay, using 3 equal partitions, okay, approximate the area under the curve. We're going to use a midpoint sum first. So let's look at our graph. And if I'm going to do 3 equal partitions, okay, what would my width be? Okay, so b minus a over n. B and a would be 3 and 0 because on the x-axis we're going from 0 to 3. And then I want 3 equal partitions, so they're going to have a width of 1. So I need to draw a line at 1, at 2, and then 3 was our boundary, and we started at 0. So here's my 3 partitions. Okay, now if I'm using a midpoint sum, okay, what is the midpoint of 0 and 1? Well, it's 0.5. So I'm going to come up the curve at 0.5, and that's where I'm going to flatten out my rectangle. Okay, what is halfway between 1 and 2? Well, the midpoint would be 1.5. So that's where I'm going to flatten out my rectangle. And again, notice some of the area is above the curve, or some of the area is being cut off. So the curve is above on one side and below on the other. Okay, what is halfway between 2 and 3? Well, 2.5. So I'm going to go to 2.5 on the curve, and that's how I'm going to flatten out and make my rectangle. Okay, so for the areas, okay, for the first rectangle, our width is 1. And then for our height or our length, we're going to do the y value when x is 0.5. For the second rectangle, our width is 1, and then our length would be the y value when x is 1.5. And for our third rectangle, this time I only need 3 because I'm doing 3 partitions. Okay, 1 for our width times f of 2.5. So when x is 2.5, how tall is that rectangle? Okay, how do we get f of 0.5? We plug into our f of x, which was 9 minus x squared. So f of 0.5 would be 9 minus 0.5 squared. So we would end up with 9 minus a fourth. Okay. And since it's times 1, I'm going to leave off the times 1 because that's not going to change your answer. F of 1.5 would be 9 minus 9 over 4 because 1.5 is 3 over 2. And again, I'm leaving off the 1's because 1 times anything is that same quantity. So f of 2.5 or 5 over 2 would be 9 minus 25 over 4. Okay. And when you put all of those together, use your calculator, put them together, you should come out with an answer of 18.25 for your approximate area. Okay, now again, notice that's not perfect because, for example, on rectangle 3, this area that I'm shading in green is too much. The area that I'm shading in blue is stuff that I left off. So they kind of even each other out, but those regions are not quite equal, so it's not perfect. Okay, but again, this method is more accurate usually than left or right sums. Okay, now let's use the same picture, but this time we're going to use a trapezoidal sum. Okay, so let's split this into our 3 partitions. So again, we're going to be a width of 1. So I need a line at 1, at 2, at 3, and at 0. But I want to make trapezoids this time. So I'm going to make my trapezoids by connecting the left side to the right side. Okay, and you'll notice this last one is not really a trapezoid. It's a triangle because our value is at 0, but we're still going to use our formula. Okay, so let's do our first trapezoid. Formula for the trapezoid again is 1/2 times the height times base 1 plus base 2. Okay, so for the first trapezoid, 1/2 times, this time our height, remember the height is actually what we were using for width on the rectangle, is 1. Our base 1 is on the left side, so that would be f of 0, plus base 2 is on the right side, so that's f of 1. Okay, for the second trapezoid, we still have 1/2 from our formula. Our height is 1. Base 1 this time, the one that's on the left side, is f of 1. On the right side, we've got f of 2. Okay, and for our third trapezoid, okay, 1/2 from the formula, a 1 for our height. Base 1 is on the left side, so that would be f of 2. And then base 2 is actually not a height at all, but it's on the left side, but that's going to be f of 3. And that's going to come out to 0, but I'm still going to write it out so that everything's in the same format. Okay, now we plug our numbers into our f of x, and remember again our f of x was 9 minus x squared. And 1/2 times 1 is just a half. So f of 0, 9 minus 0 squared is 9. When I put in 1, 9 minus 1 is 8. So 9 plus 8. Okay, and then I've got 1/2 times 1 is 1/2. F of 1 we just calculated to be 8. F of 2, 2 squared is 4. 9 minus 4 gives us a 5. Okay. And then for the third one, 1/2 times 1 again is 1/2. F of 2 we calculated to be 5. And when you put in 3, 3 squared is 9, 9 minus 9 is 0. That's why that one looks like a triangle instead of a trapezoid. Okay, so now we just have to do our addition. So I'm going to end up with 17 over 2 plus 13 over 2 plus 5 over 2, which is 35 over 2, or approximately 17.5 for our area. You'll notice that the midpoint and trapezoid sums are closer together than the left and right sums were, but we have all four methods that we can use to approximate the area under the curve. Okay, now I want to remind you, how can we make our estimates more accurate? Okay, well, obviously the method that we choose can make it more accurate, but also if we made more partitions in this graph, if I used 6 partitions instead of just 3, so if I drew another line here, okay, then these partitions are again resembling the graph a little bit closer than what our 3 partitions did. Okay, so the more partitions you use, the closer your estimate will come out to be. Okay, I also want you to remember you should always start by drawing the sketch, and don't try to save paper on this. Make them large enough that you can see what you're doing. Okay, include your partitions and draw in your rectangles or trapezoids. And if you are using the same set of conditions to do different parts of a problem, you need to draw a new graph for each one. Don't try to do a left-hand sum and a right-hand sum on the same sketch. Don't try to do a trapezoid and a midpoint on the same sketch. You need a new sketch each time you do this.